Welcome to 7.5, everybody. So 7.5 is continuing with function stuff, and in this section we're going to be graphing two different functions called the square root function and the cubed root function. So it seems a little random compared to what we were doing before, but it's still working with functions, which is why it's in this chapter. So I want you to know that what I'm going to show you next are two things called the parent functions, the parent function for the square root and the parent function for the cube root. Our method today is we're going to take the parent function and just move it. So we're going to take the parent function I'm going to show you and then translate it. So the square root graph, the parent function is y equals square root of x. So that's our regular function, no translations. And now in order to graph it, I'm going to show you a table of values for this first time. When we do our graphs, our real graphs, we're going to just translate this though, so that we don't have to make a table of values every time. Alright, so let's say I'm going through here. I'm trying to find some x's and y's. Maybe I don't really know what I'm doing, so I start out with x. I'm thinking, okay, I'm going to try x is negative 2. Oops, not possible, because I can't take the square root of a negative. So I'm going to start with 0 then, and y is square root of x. So every single time here you're going to see me put whatever I put in for x underneath a square root. Alright, so my first dot is 0, 0. Next, we'll just do a few here. Okay, up through 4. So the square root of 1 is 1. Cool. So 1 comma 1 is my next dot. The square root of 2 is 1.4. So 2 comma 1.4. Just do your best, kind of approximate it. Square root of 3 is 1.7. So 3 comma 1.7. Again, just kind of do your best to approximate it. And then last but not least, the square root of 4 is 2. And so this is my graph. And notice it started at 0 because I can't have any negative x's because I can't have the square root of a negative. With our graphs today, we are going to be talking about the domain and range. So you know how I just said I can't have any negative x's? So my domain can't be negative, so it can only be 0 or greater. So I'm going to say for the domain, x is greater than or equal to 0. And this is for the parent function domain. It's going to change when we move it. Our parent function range is the y's. Alright, to think about this, I want to say what possible y values are used in my graph. And if you look at this, y does not go below 0. It's just at 0 and above for the y's. So my range is also greater than or equal to 0, but I'll say y. Y is greater than or equal to 0. Alright, so that's one of the two graphs we're going to do. The other one we're going to do is the cube root function. So y equals the cubed root of x is my parent function. And notice for a cube root, we actually can take the cubed root of a negative. So when I try to start with negative 3, for example, it is going to be possible. And every single time, just like we did before, my function rule is the cube root of something, so I'm just going to plug in what x is and use my calculator to evaluate. So I use my calculator, and the cube root of negative 3 is negative 1.4. So my first dot is 3 comma negative 1.4. Again, just do your best to approximate that. And I'm going to keep going here. So cubed root of negative 2 is approximately negative 1.3. The cubed root of negative 1 is negative 1. Cubed root of 0 is 0. Cubed root of 1 is 1. And these are now just repeating the pattern. Cubed root of 2 is 1.3. Cubed root of 3 is approximately 1.4. Alright, so it looks something like this, and it would go slightly higher and slightly lower as time goes on. So for my domain and range this time, again, think back to what we did in previous sections. The domain is what possible x values can I use? What possible x values can I use? Well, I don't have an even root, I don't have any fractions, and that means all x values can be used. And another way of thinking about it, if you look at the graph, this is continuing to the left and to the right, and if I was going to make the world's largest graph, eventually this whole span of x values has been used. Every single one of them would be used. And the range is kind of hard to see on this one, but the same thing's happening. Even though the range it's kind of, for the y's, it's kind of increasing very, very slightly, but it's still increasing and increasing and increasing, and same thing here, like it's decreasing very, very slowly, but it is decreasing. So if I was going to make the world's largest graph, eventually all of the y values would be used. So y is also all real numbers. Now let me give you a little hint. For the cubed root graph, because it's always going to be this shape, the domain and range for any cubed root graph is going to be the same, all real numbers, all real numbers. That does not apply to the square root graph. The square root graph is going to change depending on where it moves, but the cube root graph, the domain and range will always be all real numbers. Alright, so our method today is we're going to just take those parent functions and move them. So I'm going to have the exact same graph, just translated up, down, left, right, and it could be possibly stretched or shrunk. So if you look at a formula they're going to give you, or an equation they give you for a cube root or square root graph, based off of where there are pluses and minuses, we can figure out if it's going up, down, left, or right. So for example, underneath the square root, if you see a minus sign for that value, it moves it to the right. If you see a plus sign for that value under the square root, it moves it to the left. For the k value outside the square root, if you see a plus sign, it moves it up. If you see a minus sign, it moves it down. I just want to throw out there that the left and right might have been the opposite of what you expect. Keep that in mind, but then the up and down is just as expected. The value in front stretches or shrinks our graph. And actually the same rules apply for both of these. I just wanted to write down both of the functions so you would know what it kind of looks like if it's cubed root. So you can rewrite it if you want to, but you don't have to. Alright, so for the first example here, we're just going to describe some translations. So I want to just know, how has this moved? Up, down, right, left, right. So let's just get the hang of this quick. So look back in your notes if needed. Underneath a square root, I see a subtract sign. I go back to my notes. Okay, underneath the square root, subtract sign means right. So I'm going right 3. And then outside the square root, I see a plus sign. Go back to my notes. Okay, plus sign outside means up. So this graph is translated right 3, up 4 from the original. Next one. Now I see a plus sign underneath, so that one is going left. So that one's going left 6. And now I see a minus sign outside. Look at my notes. Okay, so this one's going left 6, down 9. Pause really quick and try the next two. Look at your notes as needed. Just see if you can do it. Okay, if you have unpaused, here's what you should have for answers. The third one is left 3, up 8. And the fourth one is right 5, up 1. Flip to the back. Alright, so the first two graphs we're going to do on the back side is just translated from our original. There's no stretch or shrink yet. The stretch or shrink is by far the hardest thing you can do, so we usually always start with just the up, down, left, right. I would recommend that you always figure out what the transformations are first. So figure out how our graph is moving. And here's what I mean. Our parent function, if I was going to pick 3 critical points for our parent function, it would be 0, 0, 1, 1, and 4, 2. The other points were kind of decimals, so I didn't care about that. So that's our parent function, square root of x. And what I'm telling you is we're going to take that exact function and just move it. And I'm going to look at this and say, okay, according to my notes, I see a subtract sign underneath, so subtract sign underneath means right, so right 3. And then I see a subtract sign outside, that means down, so right 3, down 2. And to get our answer graph, we're literally just going to take every single point and move it right 1, 2, 3, down 1, 2. So right 1, 2, 3, down 1, 2. Right 1, 2, 3, down 1, 2. And that is our answer graph. Graphing the parent function is optional. You only need the one I just graphed in red to get full credit, but I recommend you graph the parent function just because it really helps out. We're supposed to also state the domain and range right now. So I just want to point out that normally for a parent function graph of square root, the domain was greater than or equal to 0. Remember that? And the range was greater than or equal to 0. The domain and range have just shifted with this starting point. So now this graph starts at 3. Really, the domain has been shifted right 3 is kind of how you can think about it. So the domain is now greater than or equal to 3 instead. And if I think about my y values, the range has now moved down 2. So instead of starting at 0, my range starts at -2. And there I go. So I got my graph, and I got the domain and range for my final answer. All right, we're going to do one more for this part 1 video. So this time my graph kind of goes off what I gave you a little bit. That's okay. 1, 2, 3, 4, up 2. Okay, so that's my parent function. And this time my translations are left 7, up 4. So I'm literally just going to take my 3 parent function dots and go left 7, up 4. And again, we just skipped these middle dots just because they're kind of decimals and hard to graph. These 3 dots were exact points, so they're easy to graph. That's why I chose those 3 points to move from the parent function. Okay, so I'm going left 7, up 4. 1, 2, 3, 4. There it is. Okay, left 7, up 4. Left 7, up 4. From the original, and there it is. So that is my answer graph. And for the domain and range, again, they have just shifted with my graph. So the domain, now the x values, has started out at -7. It's moved left 7. So I'm going to say x is greater than or equal to -7 now. And the range has moved up 4 units. So the range is greater than or equal to 4 right now. I'd say finding the domain and range is very tricky, so that's something that we're definitely going to have to talk about some in class if people need it.